Welcome, everyone. Appreciate your being here this morning. As he said, my name is Gary Vasilage. GPS, at its best, has an error of as much as 10 meters. This is the error of normal GPS. What is precision GPS? This is it, okay? So this is under 2 centimeters. We're going to hear first from James Tidd. He's the VP of Systems Engineering at Swift. We have Daniela Steinbacher, who is a project director at Bosch. We have Curtis Hay, who is a technical fellow at General Motors. And last but not least, Mark Barrett, partner of automotive/mobility practice leader at Plante Moran. I will turn it over to James.
As Gary mentioned, GNSS is to GPS as tissues are to Kleenex. It's a brand which we associate with the product. Other brands are available. It's not just GPS. There's 4 constellations. GNSS is in our lives daily. It's in our cars, it's in our handsets. It governs financial transactions. There are over 100 navigation satellites up there. The satellites send timing information down to devices. Those devices receive that information and calculate a position. But they have errors, unfortunately. The orbits aren't perfect. The clocks in the devices in the satellites aren't perfect. And they have to travel through the atmosphere, the ionosphere and troposphere, which all add error. We want to hit 2 centimeters, which means that all of those errors have to be removed in some way. GNSS in the vehicle is the only absolute position sensor, so it tells you where you are in the world, but it's part of a larger suite of sensors in the vehicle.
GNSS is a global system. It works anywhere in the world, relatively cheap from a vehicle cost perspective. It's a common reference system. When you describe your house location and latitude and longitude, it's the same language that the vehicle speaks.
The function should be integrated very easily in the vehicle, to be integrated also for every kind of architecture, and that we make reuse of the already existing components in the vehicle.
It's a really key point that all of the hardware that's required is already in vehicles today. So this is really just a software upgrade to get that 10 meters down to 2 centimeters. To estimate all of the errors I mentioned earlier, you need to have stations, so GNSS monitoring stations, deployed globally, and they then measure the GNSS signals and they estimate all of these errors and they pass it down to the vehicles. And this obviously has to be done at scale. So if you follow this, the orange line is the precise GNSS position estimator and the blue line is traditional GNSS. And as you can see, if an autonomous vehicle were to use the blue line, you would have hopefully only a bumpy ride, but definitely an unsafe ride. The benefit that GNSS has as part of a autonomous system is that its weaknesses happen when the other sensors are strong. So they're very complementary, both in how they work and how they fail. So in tunnels, you normally have a lot of features, which means camera, LiDAR, radar works very well. But as Curtis was saying, in an open highway, the feature-based perception systems struggle. But GNSS is great there.
We figured out there was a tremendous business case, a tremendous upside for autonomy, because it would enable connected and shared. And with connected and shared, you had the promise of literally billions, if not more, of revenue.
Around 70% of the brands are actively using Precision GNSS, or they have it planned for model year 27, 28, 29 vehicles. Another 20% are investigating, so they're committed to proof of concepts, and the rest of the 10% are playing catch up, really.
This stuff is rocket science. I mean, it's really amazing. So anyway, so I want to thank you guys for being here. So thank you very much.